In order for people to use computers to send and receive money, we need some kind of identity system that can be used and recognized across all computers. Usually in your country, you have public information like your name, address, telephone number, and you have private information that you can use to verify your identity, like a social security number. You must keep the private information secret, or someone could use it to steal your identity. In Bitcoin, the public information is called a public key, and the private information that you must keep secret is called a private key. The private key is just a randomly selected number. Here is an example of a private key. You might be like, what? That's a number? With normal digits, the number would be 78 digits long, so we use a different number system here which uses numbers and letters, called hexadecimal. The public key is just another number that is generated from the private key by putting it through a series of complex mathematical transformations, such that there is no way you can find the private key from the public key other than guessing. But since the public key was generated from the private key, they have a mathematical relationship, and we will later see that we can leverage that relationship for securing Bitcoin. The private key and public key together are called a cryptographic key pair. Cryptography is the practice and study of communicating securely in the presence of adversaries. In other words, being able to communicate on open channels such as the internet, where people could intercept your messages and monitor what you're sending, but having that communication still be secure. Bitcoin makes heavy use of cryptography since it is a protocol for making secure payments over the internet. Hence, it is referred to as a cryptocurrency. How exactly do we generate this key pair? There are many tools to generate these keys, as the algorithms used for generating the keys are used for many other computer applications. This tool here is called OpenSSL, which is free and available for anyone to use. But this doesn't look easy to use, so key pair generation is usually taken care of by wallet software. You've probably heard that you store your Bitcoin in wallets. Well, this is a misconception. You store your private key within your wallet so that no one can forge your identity and spend your funds. We will see how identities and the actual amounts of Bitcoin are interconnected later on. You can generate as many key pairs as you want to use on the Bitcoin network, which means an unlimited number of identities. Here we see the page of the Trezor wallet, where key pairs are generated. Note that it says address rather than key pair. A Bitcoin address is simply a shortened version of a public key. The private key isn't revealed to you because the wallet is making sure it is stored securely to avoid any user error resulting in the private key getting lost. If anyone has your private key, they can spend your Bitcoin, as we will see later on. To generate new key pairs, all I need to do is click the More Addresses button, and I get more addresses available to use. Bitcoin was made to support a higher level of privacy than a conventional payment system where you use the same payment details every time, creating a paper trail tied to your identity. In Bitcoin, you can generate as many key pairs as you want, giving you multiple identities and making it harder to track your transactions and payments. Now that all the computers have key pairs to use as identities, how can they use these to transmit payments and secure their funds? To solve this, we present the digital signature. You can think of a digital signature as a special stamp. You use the private key to make an invisible stamp on some data. Think of the public key as a magnifying glass that you can use to see the invisible stamp. If the data that was stamped is modified or tampered with in any way, or someone used a wrong private key, the stamp shows up as red. If not, the stamp will show up as green looking through the magnifying glass. A digital signature works the same way. You take some data, you take your private key, and you produce a signature using the digital signature algorithm. Then someone can take the data, the signature you produced, and your public key, and verify that the signature came from your private key. In Bitcoin, when someone has paid you, they specify an amount of Bitcoin, and they also specify a condition that needs to be met to spend the Bitcoin. This condition usually involves a digital signature of some data. The condition states, I need a signature by the person who has the private key matching this public key. This means they have addressed the payment using the public information of the recipient, which is their address. The recipient will need to use their private information to prove their identity in order to spend it. As long as the individual with the private key has stored it securely, they can generate a signature on the data and provide that signature as a part of a transaction where they spend that Bitcoin. When the transaction is validated by the other nodes in the network, they will check the signature and verify that it is valid. If the signature is invalid, the transaction will be rejected. This is why it is essential to store your private key securely. If someone is able to steal your private key, they can create valid digital signatures and spend your Bitcoin. Let's look closer at what goes into a Bitcoin transaction. Bitcoin transactions consist of inputs and outputs. The funds you have available are the outputs of previous transactions. Outputs of transactions that haven't been spent yet are called unspent transaction outputs, or UTXO for short. Suppose you wanted to pay someone 50 Bitcoin. You find the output of a previous transaction which was paid to one of your addresses, which has at least 50 Bitcoin. You reference the transaction which contains this output by using its identifier and provide the digital signature using the private key of the key pair that allows you to spend the output. The digital signature is called the unlocking script, shown by the field script_sig here. Your output will contain an amount and a condition that needs to be satisfied to spend it. This condition is called a locking script, which will require the recipient to provide an unlocking script to spend this output in a transaction, just like you did for your input in this transaction. The transaction is then encoded and transmitted to the network. Another aspect of transactions is that outputs must be fully exhausted in a transaction. If you were to pay for a $7 sandwich with $20 in cash, the cashier would accept your $20 bill and hand you back $13. Bitcoin transactions must have change as well. Here we see an output of about 1 Bitcoin used, about 0.3 Bitcoin is sent to one address, and the remaining Bitcoin is sent to another address owned by the user. After seeing those examples, you are probably like, wow, making a Bitcoin transaction is so complicated. Luckily, your wallet software will take care of most of the hard work for you. The wallet software keeps track of the Bitcoin you have received for all of your addresses. As you can see here, the wallet allows you to create accounts, which are groupings of addresses. The wallet will then tell you all of the Bitcoin you have received for those addresses. All you will have to do to send Bitcoin is specify an address of a recipient and the amount. The wallet will construct the transaction, including the inputs, the outputs, and the required digital signatures to spend your Bitcoin. It will then take that transaction and broadcast it on the Bitcoin network. To recap what we learned in this lesson, computers use cryptographic key pairs as identities. They have two parts, a public key and a private key. The public key is public information that can be shared with others on the network, and the private key is secret information. Key pairs are generated and stored by wallet software. Private keys must be kept secret as they are the most critical part of proving your identity on the network. When spending Bitcoin, you prove your ownership by creating a digital signature on some data using your private key. You include this digital signature with your transaction, and this signature will be verified by all of the other nodes on the network using your public key.